Hello. In this session, I am going to discuss the free radical addition mechanism using Bu3SnH, stannic hydride, tributyl stannic hydride. This reaction is somewhat complicated, but it is very useful from competitive point of view. Question may be asked from here, and question have already been asked from here also. See this. What is happening? It is somewhat complicated. Therefore, I have created a simple layout so that you can understand it very easily. First of all, here I am using benzyl peroxy radical. This benzyl radical is nothing but to create what it work as initiator. It behave as initiator. It is initiating the reaction. How? By reacting with Bu3SnH, tributyl stannic hydride. When it reacts with tributyl stannic hydride, it snatches hydrogen. SNH bond is somewhat weaker. This is metal with somewhat covalent character, and this is snatching the hydrogen and forming the acid, benzoic acid, and at the same time the radical is being produced, Bu3SN radical. And once this radical is produced, it will go for further reaction. Now the reactant is PHCH2Br, benzyl bromide. With benzyl bromide, it snatches bromine. Tin being metal, it snatches bromine. The carbon-bromine bond is somewhat weaker, and it forms Bu3SnBr and liberate and form another radical, benzyl radical, PHCH2 radical. See this. One radical is creating other radical. This is propagation step. This step is propagation step. Bu3SN radical is creating PHCH2 radical and itself get neutralized by forming Bu3SnBr. Now this PHCH2 radical, the benzyl radical, will add with acrylonitrile CH2 double bond CCN. Here we have 3 carbon. CH2, CH and Cn, nitrile. And here it add with this carbon, forming a radical here adjacent to the cyanide group. Adjacent to the cyanide group, we have a radical. This is your radical addition. PHCH2 add here and another radical is formed. Now this radical, this radical will decay. How this will decay? This will snatch hydrogen from Bu3SnH, stannic hydride. From other molecule of stannic hydride, it will snatch hydrogen and form pH and form addition product. 1, 2, 3 carbon, 3 carbon from acrylonitrile and pH and CH2 from PHCH2Br. In this way, your benzyl group get added with acrylonitrile via free radical mechanism. This is important. Let us see one question that is based on this concept only. See, here is the question. Which radical is not involved as an intermediate in the following reaction? See this. Which radical is not involved as an intermediate in the following reaction? PHCH2Br plus acrylonitrile plus Bu3SnH. Here AIBN, azo-isobutyronitrile, is used as a radical initiator in place of any other peroxy radical, and this is your product plus Bu3SnBr. Just see which is not being formed. In the whole process, since we have gone through the mechanism in detail, we can see that AIBN first react, AIBN snatches, gives radical, the radical react with Bu3SN, the H goes with AIBN radical, and Bu3SN radical is formed. This implies second is correct. Second is formed. Second is not the answer. Bu3SN radical react with PHCH2Br and snatches bromine radical. It will form Bu3SnBr. Bu3SnBr and create PHCH2 radical. This implies one is also not the answer. PHCH2 radical is produced. Now this PHCH2 radical react with the nitrile, it will react with this carbon and this radical is produced. Okay, this is also here. Therefore, C is not the answer. 3 is also not the answer. Then what is the answer? The answer is 4. In the whole process, Br radical is not produced. Remember, in all other cases, if I am using HBr with peroxide, Br radical is produced. At many of the places we get Br radical, but not here. Here Br radical is not produced. Okay. With this, this role of the mechanism using SN hydride is complete, and we will discuss further. In the next class we will discuss the addition reaction and also see the question based on the radical reactions. Okay, thank you.